Hello viewers, in today's class we are going to discuss an important problem from trigonometric equations, right? And here we have a very interesting problem that goes like this. If 3 cos x plus 4 sin x is equal to 2 alpha plus 1, it has a solution, that is this equation has a solution. Then we have to find the sum of the squares of all the possible values of alpha, right? And here four options are given, and we have to find the correct option, right? So what we have given here, we are given an equation that is 3 cos x plus 4 sin x is equal to 2 alpha plus 1, right? And here we have to find all the possible values of this parameter alpha, and then we have to find the sum of the squares of all the possible values of this parameter alpha, right? So let us start. So here what we will do, we'll take help of some elementary trigonometry, right? Let us take a triangle, right? So here we have a right angle triangle. This is A, this is B, and this is C, right? Let us take this angle as theta, and this is the 90 degrees, right? Now let us take this side, that is AB, which is the perpendicular, as 3 and the base as 4, right? Then by Pythagoras theorem we can easily find out this the length of this hypotenuse, that is 5, right? So now if we take this right angle triangle and we find sine theta, then sine theta is perpendicular over hypotenuse, that is 3 over 5, right? And cosine theta is equal to uh, that is base over hypotenuse, that is 4 over 5, right? Okay, now see, here we have 3 and here we have 4, right? So now what we will do, we'll divide both sides by 5, right? So because once we divide both sides by 5, here we'll get 3 over 5, which is sine theta, and here we'll get 4 over 5, which is cos theta, right? So here we have 3 over 5 cos x, and here we have 4 over 5 sine x, and here we have 2 alpha plus 1 over 5, right? Now we can replace this 3 over 5 by sine theta. So we have sine theta, and here we have cos x, and 4 over 5 can be replaced by cosine theta, and here we have sine x, right? And this is 2 alpha plus 1 over 5. So now if we look at this expression, then this is the well-known formula in trigonometry, right? That is sine a plus b is given by sine a, then we have cos b, and then we have sine b and cos a, right? So here this expression, that is theta can be taken as a and x can be taken as b. So we have sine a cos b plus cos a sine b, right? So now this expression can be written as sine theta plus x, right? By using this result. And this is 2 alpha plus 1 over 5, right? Now we have a very important equation here. So now see, here we have in the left hand side sine theta plus x, right? Now if we consider the range of sine function, then we know that sine of say beta always lies between -1 and 1, right? And here we have theta plus x, right? So if we replace theta plus x by say beta, then we have sine beta is equal to 2 alpha plus 1 over 5, where beta is theta plus x, right? Now this sine beta must lie between -1 and 1, right? Because sine beta belongs to the interval -1 to 1, that is the maximum value of sine function is 1 and the minimum value is minus 1. So now let us substitute this value of sine beta in this inequality, right? So what we will have, we have minus 1 here, and here we have 2 alpha plus 1 over 5, and here we have 1, right? Now let us multiply this inequality throughout by 5. So what we will get, here we'll have minus 5, here we have 2 alpha plus 1, and here we have 5, right? Now let us subtract 1 throughout, right? We'll subtract 1 throughout. So we have minus 5 minus 1, and here we have simply 2 alpha because 1 and minus 1 is 0, and here we have 5 minus 1. So now we have minus 5 minus 1 is minus 6. Here we have 2 alpha, and this is 4, right? Now let us divide throughout by 2, right? So we have here minus 3, here we have alpha, and here we have 2, right? So now we have obtained this inequality, which suggests that alpha lies between minus 3 and 2, including minus 3 and 2, right? So now if we take the real number line, here we have 0 minus 1 minus 2 minus 3, and this is 0 and 2, right? So alpha takes the values minus 3 minus 2 minus 1 0 1 and 2, right? So the possible values of alpha are given by minus 3 minus 2 minus 1 0 1 and 2, right? So these are the possible values of alpha, and here we have to find the sum of the squares of all the possible values of alpha. So if we take the square of minus 3, then minus 2, then we have minus 1, and then we have 0, then we have 1, and then we have 2, right? So this is 9, this is 4, this is 1, this is 0, then we have 1, then 4, right? So this is 13 plus 1 14, plus 1 15, plus 4 19, right? So the sum of the squares of all the possible values of alpha is 19. So the option C is correct. So viewers, this is how we can solve these type of problems.